One more problem of second order homogeneous differential equation. A luggage weighted 2.5 slugs expands the spring up to some inches with a damping force equals to 16 lb at t equals to 0.5 second for the velocity feet per second and k equals to 80. How long the luggage will be displaced if the initial condition is y of 0 equals to 1 and y prime of 0 equals to 15. The statement says that there is a luggage weighted 2.5 slugs with a damping force equals to 60. Now if we apply the initial condition, how long the luggage will be displaced after 0.5 seconds? That is the task that we need to do. Solution. Let me draw the spring mass system. Initially the luggage is at equilibrium position, which is 0, and when I stretch it up to some inches here and then released it down, well, this is my delta L. So the equation will be m y double prime plus cy prime plus ky equals to 0. This is a second order homogeneous differential equation. It's y double prime and therefore it is second order homogeneous differential equation. K is the spring constant. Now substitute the values of m, c and k here. The value of m is 2.5 slugs and the value of c is 60. The value of k is 80. Divide both sides by 2.5, which equals to y double prime plus 24y prime plus 80y equals to 0. Change the equation into differential operator form d squared plus 24d plus 80 equals to 0. This is my new equation in differential operator form. Now I'm going to find the roots. To find the roots, this equation can be written d squared plus 20d plus 4d plus 80 equals to 0. It is a simple factorization method. Solve the equation further, you will get d sub 1 equals to minus 4, d sub 2 minus 20. Here the roots are not equal to each other, therefore I'm going to use this equation y equals to c sub 1 times e to the d sub 1t plus c sub 2 times e to the d sub 2t. Remember, in the previous problem we had the roots that were equal to each other. The equation was different, and now the roots are not equal to each other, and therefore this equation will be different. Substitute the values of d sub 1 and d sub 2 here. So this is my new equation. Take its derivative, you will have y prime equals to minus 4 times c sub 1 times e to the minus 4t plus into minus 20 times c sub 2 times e to the minus 20t. Now to find the values of c sub 1 and c sub 2. It's from the initial conditions where y equals to 1 and y prime equals to 15. T equals to 0 here. Take the first equation, y equals to c sub 1 times e to the d sub 1t plus c sub 2 times e to the d sub 2t. Substitute the value of y equals to 1 and t equals to 0. Solve the equation further. You will get the equation c sub 1 equals to 1 minus c sub 2. Now take the second equation and substitute the value of y prime equals to 15 and t equals to 0. Solve it further. You will get c sub 2 equals to minus 19 over 16. Substitute this c sub 2 in this equation and solve it further. You will get c sub 1 equals to 35 over 16. So my c sub 1 is 35 over 16 and c sub 2 is minus 19 over 16. Just put these values for c sub 1 and c sub 2 here. Another challenge was that after 0.5 seconds, how long the luggage will be displaced. Just substitute the value of t equals to 0.5 second. Simplify the equation, you will get y equals to 0.3 meter. Change 0.3 meter into feet, which equals to 0.98 feet. So the luggage will be displaced up to 0.98 feet after 0.5 seconds.